Hey everybody, it's Mr. N, and we have another quick calculus AP test review. This is part 4 in our series for 2024, and we have an FRQ question today. So let's take a look at this. It says, find the particular solution to the differential equation dm dt equals 1/6 minus m with initial condition m of 0 equals 8, and then m of t is less than 60 for all values of t. That'll help us here in a bit. Now, typically, this is part of a couple other questions, and this would probably be part like C or D towards the end. The other ones, you may have to find a tangent line with this just to be aware of that, but this is just typically the hardest part, which is the most points that you can earn. So let's go ahead and dive into this and see what we have. We need a particular solution. That means we need to do some differential equations. All right, so that means we need to take this equation right here and separate the variables. So let's go ahead and put the m's on the same side. So we have dm, and I will divide this by the 60 minus m and put that there. And I'm going to put the dt on the other side with the 1/6 dt. It certainly isn't incorrect if you put the 6 on that side with the dm and work at it that way. It just makes the problem a little bit more difficult. So now at this point, we want to go ahead and integrate. So we will integrate this and this side. And then we will end up, when we integrate this, we're going to end up with a natural log of 60 minus m. And if you test this, if you have ln of 60 minus m, that absolute value, you would take the derivative, that's 1 over 60 minus m. I'm doing a guess and check method, times, now I have to take the chain rule here. So that would be -1. So be careful with that. So that means we need a negative out in front of here. And on this side, when we integrate, we're just going to get 1/6 t plus the c. You only need the c on one side, so we will keep it on that side. All right, so moving on from this, now let's go ahead and plug in our initial condition so we can solve for this. So we're going to use the initial condition of, in this case, m of 0 being 8. And let's plug this in. So we end up with negative ln of absolute value of 60 minus 8 equals 1/6. And then this was 0 for t. And we get plus c, so that will go away. And this ends up being negative ln absolute value of 52 is my c. And you can get rid of the absolute values at this point, and you could just say that this is negative ln of 52. All right, so now plugging it back in. So this is our constant, and we want to plug it back into this equation that we got right here to be able to find a solution. All right, so now plugging this in, I end up with negative ln absolute value of 60 minus m, and this equals 1/6 t minus ln 52. And now cleaning this up, we can take this negative, and I'm going to take it over to the other side. It's much easier if we work at it this way. So I will end up with this as being, I'll write it here on the side, ln absolute value of 60 minus m equals, this will be negative 1/6 t, and this will be plus the ln of 52. All right, so now we want to solve this. So what I'm going to do is I will take, let's change colors here real quick. I will take e to this and e to that, because that's how I'm going to get rid of the natural log. And let's move this up just a little bit. And over here, we're going to now end up with, this reduces itself out. So I'll have 60 minus m, and I can get rid of the absolute value at this point because it tells me up in the problem, the m of t over here is less than 60. So I can get rid of it at that point because I already know it's going to end up being that based on my initial conditions and constraints. So this ends up being 60 minus m equals e to the negative 1/6 t plus ln of 52. Now this can be broken apart into negative 1/6 t like that times e to the ln 52. So that reduces out, and I'll just have the 52 right out in front right there. So 60 minus m equals the 52 e to the negative 1/6 t, And now just cleaning this up, we'll finish this problem right over here. I can say m of t is going to be equal to, this is my m, I'll bring it to this side, I'll bring the other one to the other side, so 60 minus 52 e to the negative 1/6 t. So there you go. Again, this would be part C in a problem, but this would be worth the most points, which usually is going to be around 5 or 6 out of the 9. All right, thanks for watching. Hit that like, subscribe, and I'll see you guys in the next video.